Hey there, and welcome. We're about to talk about something you probably use all the time, but might not fully understand your air conditioner. Because here's the thing that wonderful machine that saves you on a hot day, well, it doesn't work at all like most of us think it does. So let me just ask you, straight up, do you think air conditioners create cold? I mean, it sure feels like it, right? You flip a switch, and this wonderfully cold air starts pouring out. Seems pretty open and shut. But what if that's just an illusion?
You see, this is where we get tripped up. We have this idea, this flaw in our thinking. We assume an AC is just a heater in reverse. A heater makes heat, so an air conditioner must make cold. It makes perfect sense on the surface, but it's just not right.
And here's why. This is the one scientific fact that just completely flips the script. In the world of physics, cold isn't really a thing. You can't add cold to a room. Cold is just what you get when you take the heat away. It's the absence of heat energy. So this is the perfect way to reframe it. We think of our AC as this magical cold-making machine, but what it really is a heat-moving service. That's its job. It's not a creator, it's a transporter, right? So its real job is all about relocating energy, specifically thermal energy, which we all know is heat. It takes the heat from a place you don't want it, like, say, your bedroom, and moves it to a place where you don't care about it, like outside. And you know what? There's a technical name for this kind of technology. It's called a heat pump. And honestly, the name says it all, doesn't it? It is a pump for heat. Its whole purpose is to move heat from one place to another. I love this analogy. Just think of your AC as a little relocation service for energy. It's like it packs up all the unwanted heat inside your house into tiny moving boxes and just unceremoniously dumps them on the curb outside. Okay, so how? How does this little heat-moving company actually do its job? What's the engine that's making all this happen? Well, that brings us to a beautiful piece of engineering called the refrigeration cycle. This cycle is a totally self-contained, closed loop that has a special fluid inside called a refrigerant. Now, you can just think of this refrigerant as the moving truck. It's the vehicle that's constantly picking up heat inside, driving it outside, dropping it off, and then racing back in to grab another load. All right, let's follow one of those little trucks on its journey. We're going to trace the path of heat from inside your room all the way to the outside world. It's a simple 4-step process, and once you see it, you'll realize it's not magic at all. It's just incredibly clever physics. So here's the roadmap. We start inside at the evaporator, then the refrigerant goes to the compressor, then outside to the condenser, and finally it passes through the expansion valve to start the whole trip over again. Let's look at each one. So step 1 happens inside your house, in what's called the evaporator coils. You have this really cold, low-pressure liquid refrigerant. When your AC's fan blows your warm room air over those coils, the heat in the air literally gets soaked up by the refrigerant, and all that absorbed heat makes the refrigerant boil and turn into a gas. It has now officially captured the heat. But hang on a second. Here's the puzzle, right? How can you dump heat outside when it's already like 95 degrees out there? Heat doesn't naturally flow from a cool place to a hotter one. Well, this is where the real secret sauce of the system comes into play. And here it is. This is the absolute aha moment of the whole system. That gas, now carrying the heat from your room, gets sent to the compressor. This is the heart of your AC unit. It does one job. It squeezes that gas really, really hard. And here's the magic trick of physics. When you put a gas under pressure, its temperature goes way, way up. So now, that refrigerant is a super hot gas, much hotter than the air outside. Now that the refrigerant is super hot, it gets sent to the outdoor unit, to the condenser coils. And because it's now so much hotter than the outside air, the heat just naturally wants to escape. It radiates away from the coils and into the atmosphere. The heat has been successfully delivered and dumped outside. And as it loses all that heat, the refrigerant cools down and turns back into a liquid. Okay, final step. We just need to hit the reset button. That now high-pressure liquid travels through a teeny tiny nozzle called the expansion valve. This causes a massive, sudden drop in pressure, and just like squeezing the gas made it hot, this rapid depressurization makes it instantly plummet in temperature. And just like that, it's a super cold, low-pressure liquid again, ready to go back inside and pick up its next load of heat. And that's it. That's the whole cycle: evaporation, compression, condensation, expansion, over and over and over, just pumping heat from inside to outside. So let's just quickly recap the big ideas here. If you take away anything from this, let it be these three things. Number one, cold isn't real. It's just what's left when you remove heat. Number two, your AC is a heat pump. Its entire job is to move heat, not make cold. And number three, the whole magic trick is powered by the refrigeration cycle, which cleverly uses changes in pressure to control temperature and get heat to go where it normally wouldn't.
So that leaves us with one last little question to chew on. We've just seen this amazing system that's brilliantly designed to move heat out of your house. So what do you suppose would happen if you could make that whole cycle run in reverse? Just something to think about. Thanks so much for tuning in.